Next, we want to do division with polynomials by dividing by a polynomial, something more than just one term. Now, this kind of division is very similar to long division with whole numbers. There's not very good explanation behind it. I'm just going to show you one of these problems. So I have 6a squared plus 5a plus 1 divided by 2a plus 3. So I'm going to set this up as a long division problem, similar to long division with whole numbers. There's not going to be much explanation as to why this works, only that it does work. I start by estimating how many times 2a divides into 6a squared by asking what number do I multiply 2a by to get 6a squared. The answer is 3a. Now I multiply 3a times 2a squared. 3a times 2a is 6a squared. Now 3a times 3 is going to be 9a. So first I did an estimate, then I multiplied. Now I'm going to subtract this polynomial from this one. I subtract by changing the signs and adding. 5a plus negative 9a is minus 4a. 6a squared plus negative 6a squared is 0. I bring down my next term. And I ask myself, how many times does 2a divide into negative 4a? So I want to know what number I multiply 2a by to get negative 4a. The answer is negative 2. Now I multiply negative 2 times 2a, negative 4a. Negative 2 times positive 3 will be negative 6. I want to subtract this polynomial from this one, so I change the signs and add. 1 plus 6 is 7. Negative 4a plus 4a is 0. So this polynomial divides into this polynomial exactly 3a minus 2 times with 7 left over. So I can write my answer this way. 6a squared plus 5a plus 1 divided by 2a plus 3 is 3a minus 2 plus 7 over 2a plus 3. And in a way you can think of it like this. There's 7 that's still to be divided by 2a plus 3. So here's my quotient plus, it looks like a remainder divided by 2a plus 3. So those are the steps in long division with polynomials. Make an estimate, multiply, subtract by changing the signs and adding, then bring down the next term. Try a few of these on your own and see what you can come up with.